I've been asked to speak today about innovations in manufacturing regarding reliability and planning. As Benjamin Franklin once said, an ounce of prevention is worth a pound of cure. As these gentlemen here found out, they didn't have enough prevention, so they got broke down on the racetrack. I have a lack of pictures, so I have a little more. Prevention versus remediation, which offers more value? Creating value in the upstream oil and gas industry can be challenging and persistently driven, price-driven market. One area where every operator and service provider should be looking is project planning when they're building the new equipment. I've worked in this industry for over 30 years and have seen the different approaches into planning and existing projects. Generally speaking, I've found that if it ain't broke, don't fix it, and a quest for constant improvement. The first category is one of status quo, where new ideas and technology are not considered, often to result in either an overspecified or over-designed or approach to building new equipment, otherwise based on a person's knowledge of who's in charge of the project. The second category includes efforts of systematically reduce the risk of operational problems, i.e. taking a preventative approach rather than waiting for problems and then remediating. This can take various forms in the oil field, which I'm sure we've all seen. But over time, I have observed a reoccurring theme. It is rare that planning for failure and remediation offers a better value than prevention. Consider a couple of analogies from the automotive world. Most vehicles have a maintenance schedule where you change your oil at certain intervals and or mileage. And another example is corrosion. Preventing a car from rusting is much easier than repairing it after it starts to rust. And many issues are harder to address if you wait for a problem to occur and then remediate. Another consideration is financial risks. In any project, it is necessary to understand commercial risks. Unlimited investment to prevent risk is likely not appropriate business decision, and eliminating risk entirely is often not the end goal. A balanced approach that seeks to reduce the risks of the lowest level that is reasonably practical can drive better decisions. If the risk is a commercial risk, an analytical approach can be used to estimate the probability that a risk will occur and the associated cost. From these estimates, you can calculate and return on investment for a prevention strategy. In simple terms, this is your value proposition for equipment, tools, product technology, process, or action. There's a tendency to second guess decisions once we've made these decisions to do preventative planning because once you've done it, your costs go down because you're planning your repairs instead of reacting. Then they get into the absence of the problem, so why are we doing this? Why are we spending money preventatively when it's not costing us anything? So they get back to the old habits. One of the things I would encourage, and we encourage our engineers and operators to build a preventative approach in their project designs while they're designing the new equipment, involve the operators and the engineer in the design. While understanding the commercial risks, as stated earlier, planning for failure and remediation is rarely a better value than prevention. By utilizing reliability engineering, which provides the structured foundation or for identifying and prioritizing critical assets, since nearly all equipment requires some form of inspection and maintenance procedure to monitor their integrity and health conditions, to prolong life, or to prevent catastrophic failures. We have the technology today to prolong life and prevent catastrophic failures by using automated diagnostic systems to monitor equipment. Combining this approach with financial data, businesses can make risk-informed decisions to provide most value through increased safety, reduced downtime and non-productive time, improve efficiency, and improve performance. ways we strive at Wrangler and Coil Solutions to improve our life cycle for our clients' equipment and for lubrication, for example. We use magnetic filtration carts for all lubricants going into fluid systems. We use proper lubrication for the application and temperature conditions, using the best-in-class components when manufacturing, like magnetic filtration. We install the best absorbent filters, breather filters on hydraulic units to keep the water out. We use earth magnetic plugs on gearboxes, transmissions, planetaries, drive differentials. We design improper oil ports for monitoring the lubrication conditioning, and we offer maintenance training for operators and other, as they are the first line of defense in running the equipment. On top of designing proper lubrication cleanliness systems, we can go into mechanical and operational designs in order to reduce built-in problems that occur at the manufacturing level, which is what Dale blames on the OEMs. And this is an example of one of the units we just recently finished. Here we have a line of 5 high-pressure magnetic filtration units. As you can see, we've installed them for ease of cleaning. We have a platform here, easy accessible. The magnetic filter rod comes out to the top so you don't have any spillage or environmental contamination. And on the other side, we have the return filters for the hydraulic tank.
I have a question.
Sorry.
I have a question. When you clean those filters, do you wipe them down with a belly pour and inspect them?
Yeah, so what we've, and we have had Roger to assist us with that, with this particular customer, because he's never had magnetic filters. So what we've done, and I don't know if Roger's got the oil sample back for that, but when they just did a test and the rods were fairly clean. They said there's not much on them now. So that we had them wipe it with a white rag and then fold it in and take an oil sample and send it in so we can get tests on it. A white rag works really good because it gets, as the system gets cleaner and cleaner, the particles get finer and finer until you can hardly see it, and you pull the rod out and they say, well, there's nothing on there. But you wipe it with the white rag, and that's where I've got a misnomer here. I got below 1 micron, but it actually cleans to sub-micron, so but I'll have to correct that, Roger. Our belief with our company, and it's my belief, I come from a maintenance background, and so I'm driving it home with all of our designs, from our engineers to our operations personnel. Our belief is more involvement from operations, maintenance, and safety personnel in the design process for manufacturing their equipment would result in more reliable, cost-efficient equipment. It will cost a little more up front, but over the life of the equipment, the ROI will be exponential, as it will result in increased uptime, reduced downtime, increased safety, lower maintenance costs due to the failures during operation. I believe this would also help to attract best operators that you want in the industry, because everybody wants to run the best equipment. Unfortunately, the people making the decision when they go to purchase the equipment and manufacture it are looking at what's it costing me today. They don't take into the fact that what's it going to cost me tomorrow. So in order for an OEM to get the contract, we have to lower our cost. In order to lower our cost, you reduce the best in practice components in order to get that. One thing that we've been trying to teach, or trying to inform our customers, is that if they put in the best components, the best reliability packages, it will not only make us shine, but it will make them shine to their customers. And in the oil and gas industry, now that the oil price is below $50, everybody's looking at cost. They don't want downtime, and their customers are demanding zero downtime. In conclusion, as Woody said, one of the things that he finds as the end user, there wasn't enough planning in the process, so he's got welded components and components that he can't put the magnetic filtration or better filtration in, so you have to do it on the backside or customize, which costs more money. So at the end, if we plan properly in the design process with the customer and ask all the operators that are running it the problems they see, then we can build components and equipment properly with the reliability in mind. So the more we do to design stage, we'll, with input from all stakeholders and using the best technology available at the time, will increase reliability, safety, reduce costs, and downtime. Use the best available solutions when building equipment to reduce premature wear and failure, like magnetic filtration, operation monitoring systems, oil sampling, vibration analysis, thermography, etc. We have the tools today to prevent premature failure. We just need to use them. We need to consider the cost of ownership over the life of the equipment, not just the cost to acquire the equipment. And that's my presentation, short and sweet. So.
Question.
Yes, sir.
I mean, we speak here microns and particles and that, but you're a manufacturer. Do you present a quantified business case to your customers to show the return on equity or your return on investment? Because that seems to be the...
Yes, and that's the tough sell. So we're building, again, we're relatively new on the large equipment side. We started in February of this year. Well, we started in 14, but oil downturn pushed us out. But anyway, so we're building those case studies, and we're working with customers that are buying into the program. Our service department, every unit that comes in, we present them with options for the magnetic filtration. Thanks, Phyllis. And the cost savings, just the savings alone in oil changes. The fact that you never have to wait and can't change that oil because you don't have that filter element, because you buy once, you don't have to pay again. There's no reason for delaying to clean the filter. Because again, this system doesn't have bypass, because it doesn't plug off, it doesn't restrict flow. It reduces your fuel cost consumption because you're not using that horsepower just to pump fluid through filters. To me, this is one of the best filtering systems there is, bar none.
Have you ever had to, do you have any data, or have you ever had to replace any of the one-eye filters?
Never had to replace a rod as far as anything that we've sold. And I've known Roger for quite a few years when he first started developing this. And to date, I don't believe you've replaced anything in the past 15 to 17 years that you've been doing it. Yes, so the first ones are out there today and still working. Any other questions? Thank you very much for your time. Short and sweet.